Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at negative indices. Remember, indices are powers, so we're looking at what happens when the power is negative. So we're going to first look at what 2 to the power of negative 1 would equal. Now, we sort of have to abandon our wisdom here. We are so used to thinking of this power as telling us that we multiply this number by itself this many times. We can't use that logic here though. You can't multiply 2 by itself negative 1 times. You can't do anything negative 1 times. So how are we going to say what 2 to the power of negative 1 equals? Well, what we're going to do is we're going to define 2 to the power of negative 1 so that it's consistent with other index laws. So what I mean by that, 2 to the power of negative 1 times 2 to the power of 1. Our previous index law of multiplying bases, we know that that is keep the same base, add the powers. Negative 1 plus 1 is 0. But we know that 2 to the power of 0 is 1. So we have that 2 to the power of negative 1 times by 2 equals 1. This is just equal to 2. So I don't know what 2 to the power of negative 1 equals, but I know that when I multiply it by 2, I get an answer of 1. So that means 2 to the power of negative 1 must be equal to a half, because a half is what you multiply by 2 to get 1. Essentially, I've just divided this side of the equation by 2 and divided this side of the equation by 2. So 2 to the negative 1 is a half. That's a bit unexpected. We might have thought we would get a negative answer, like negative 2. But when you raise a positive number to a negative power, you still get a positive answer. You can't actually raise 2 to any power and get a negative answer. So 2 to the negative 1 is a half. So what would be 2 to the power of negative 2? Well, that's just the same as 2 to the power of negative 1 squared, because of the power to a power rule. We just multiply the powers. So 2 to the power of negative 1 is a half. So half squared is a quarter. This has just given us a quarter, or the same is 1 over 2 squared. And you can probably guess 2 to the negative 3 is going to give us 1 over 8 or 1 over 2 cubed. So again, the reason that it equals what it does, the reason 2 to the negative 3 is 1 over 8 is just so it's consistent with other index laws. So this is a formal way to say what we have learned. If you're raising something to a negative power, you just move it to the bottom of the fraction and write it with a positive power. So let's go through some examples to elucidate this. So 5 to the power of negative 3 is just going to be 1 over 5 to the power of 3. We moved this to the bottom of a fraction and changed the power to positive. So similarly, x to the power of negative 7, we're going to put it on the bottom of the fraction, write it with a positive power. So how would we do something like this? Well, we need this rule here. Anything with a positive index goes on top, anything with a negative index goes on the bottom. 2 is the same as 2 to the power of 1. It actually has a positive index. So another way we can look at it is just put on the bottom anything that had a negative power, but change it to positive, and everything else goes on top. What about something like this? Well, b has a positive power, so it's going to go on top. Now, the 2's already on the bottom, so we're going to leave it there. We're going to change the a to a positive power and move it to the bottom. We're going to change c to a positive power and move it to the bottom. So what about something like 1 over a to the power of negative 5? So a to the power of negative 5 is just 1 over a to the power of 5. And using the rule of fractions, this just gives us a to the power of 5. So what we can see is if you have a negative power, you can move it to the bottom of the fraction and make its power positive. But if you have a negative power on the bottom of the fraction, you can just move it to the top of the fraction, get rid of the fraction, and change its power to positive. So for 2 over x to the power of minus 6, we're going to leave the 2 alone, and we're going to move the x to the minus 6 to the top, but we're going to change its power to positive. So basically what is happening is when you have a negative power, change it to positive. But when you change the power to positive, you need to move it to the bottom of the fraction if it was originally by itself, or you need to move it to the top of the fraction if it was originally on the bottom. So now we're going to look at what happens when you raise a fraction to a negative power. So when you raise a fraction to a negative power, you simply flip the fraction and make the power positive. So 2 over 3 to the power of negative 1. All I'm going to do is flip the fraction, change the power to positive. Of course, 3 over 2 to the power of 1 is just 3 over 2. And this works when you have pronumerals as well. X over y to the power of negative 2. I simply flip the fraction and I change the power to positive. And using a previous index law where we raise a fraction to a power, you simply raise the top to that power and raise the bottom to that power. Let's do one more example. A cubed over b, 4 to the power of negative 5. So we simply flip the fraction and we change the power to positive. So using previous index laws, we're going to raise the top to the power of 5. So keep the same base, multiply the powers. And then we're going to do the same to the bottom. Keep the same base and multiply the powers. All right, let's now look at a harder question where we use negative indices with other index laws. So we're going to simplify this fraction, leaving our answer in index form. So there is a bit to do here. It looks complicated, but don't panic. We're just going to do it bit by bit. So let's first look at the top. So the 3 is outside the brackets. It's not being raised to the power of negative 4. So what I'm going to do is leave the 3 alone. So we remember to do something like this, we're going to keep the same base and multiply the powers. So 2 times negative 4 actually gives us negative 8. Now, y to the power of negative 3 to the power of negative 4. We're going to keep the same base and multiply the powers. Negative 3 times negative 4 is positive 12. Now let's do the bottom. This time the 3 is inside the brackets, so we are going to raise it to the power of negative 2. So 3 to the power of negative 2 is 1 over 3 squared, or 1 over 9. Now we raise x to the power of negative 2. And we have to raise y to the power of negative 1 to the power of negative 2. So to do this one, you keep the same base and multiply the powers. Negative 1 times negative 2 gives you positive 2. So now let's simplify this further. So we're going to do the numbers separately. So 3 divided by a ninth is actually 27. You can use your calculator if stuck with that. X to the negative 8 divide x to the power of negative 2. You keep the same base and subtract the powers. Negative 8 subtract negative 2 is negative 6. Y to the power of 12 divided by y squared just gives us y to the power of 10. So to simplify this fully, we need to write it with positive indices. So things that already have a positive index go on top. The thing with a negative index goes on the bottom, and we change its power to positive, and we can't simplify any further. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.